In today's lesson, we'll be looking at an algebraic way of solving a system of equations. We've been working with graphing ways, which are pretty straightforward and makes sense. We graph it where the cross is the solution. Now, the issue with graphing is sometimes it can take a little bit longer, but the main issue is there's approximations that we do. We can't always read the value accurately. It doesn't always end up being a crosshair on our grid. It ends up being a fraction or a decimal, and we end up doing estimates, and our answer isn't very accurate. So we rely on an algebraic method to give us more accurate results. And there's two algebra methods that we're going to talk about. So today's method is called the substitution method. Okay, and it involves 4 steps. So the first step is to look at your system equations here. So we're looking at A, and we're going to rearrange one of the equations to look like x equal to something or y equal to something, right? And you just pick the one you think that's going to be easier to do. So I'm looking at this, and this one looks like it's pretty easy for me to manipulate. I'm going to write this down as x is equal to 17 minus 4y, and just move the y term over to the other side. So now our goal is to come up with an equation where we only have one variable. But because we can't do anything with the equations that we're given here. We can't come up with a value because we have 2 unknowns. Okay, so now here comes the substitution part. So we have 2 equations. I'll call this equation number 1, and I'll call this one equation number 2. And I'm going to say we're going to substitute equation number 1 into equation number 2. Right? So what I mean by that is equation number 1, we rewrote it x equal to something. So in equation 2, where we see the x, we're going to replace it with equation number 1, because that's what x is equal to. It's equal to a number, but it's also equal to this expression, right? So we have our second equation. We have 2, and there's the x, so I'm going to substitute equation number 1 in. So equation 1 is 17 minus 4y. Then we have the remainder of our equation 2 minus y is equal to 7. All right. Now we clean this up and we solve for y. Right? We bring the 2 through the brackets. So 2 times 17 is 34. 2 times negative 4y is negative 8y. Negative y is equal to 7. Okay, I'm going to collect some terms here. Negative 8y and negative y becomes negative 9y. We still have the 34 here, and we have the 7 to this side. So we subtract 34, bring it to the other side. So we have negative 9y is equal to negative 27, that would be. And 7 minus 34, negative 27. Then divide by negative 9 on both sides. So 27 divided by 9, we end up with y is equal to 3. So now we have our y value. We need to find our x value. So we take our y value that we have and we plug it back into equation 1 or 2 and we solve for x. Now, this manipulated equation over here, it's already x equal to something. So we can just stick the value of y in there and get our x value out. So x is equal to 17 minus 4y. And I plug in the y value of 3. So it becomes 17 minus 12, which this then turns into x is equal to 5. So our solution is x is equal to 5, y is equal to 3, or in coordinate forms, 5, 3. Okay, so try this on example B here. Pick one of these equations, turn it to x equal to something or y equal to something, and solve. Actually, how about we, before doing it, let's call this equation 1. We'll call this equation 2. Okay? And so your answer follows the same steps as mine. Let's make equation 1 solve for y equal to something, and we'll substitute it into 2. Okay? So stop the video and give it a try. Rewriting the first equation, you should end up with y is equal to negative 4/3 x. Now we're going to substitute 1 into 2. So wherever we see the the y in this case, we're going to stick in the first equation. We multiply it through. 8x becomes 8x plus 12x is equal to 5. We collect our terms. It becomes 20x equal to 5. We divide by 20, which is 5 over 20. And we simplify that down. It becomes x is equal to 1/4. Right? Then we take our x value, we plug it back into one of the equations, and we get our y value out. So we stick in the value of 1/4 in, and we see that y is equal to the negative 1/3. So the solution for this system is x is equal to 1/4 and y is equal to negative 1/3. Right? So I think the general concept is fairly straightforward, and the errors that typically students have with this are arithmetic errors. Either you don't multiply through the brackets correctly, or you end up making adding or subtracting errors when you are collecting terms or moving from one side of a term from one side of the equation to the other. In this next question, I'm going to up the difficulty level slightly. Right? All the questions we worked on before this had integer coefficients, but this time we're going to have fractions involved. The steps are the same, but the arithmetic just gets a bit more difficult because we're using fractions. Right? Our first step is to determine which equation we want to equal x equal to something or y equal to something. Now the second equation here is already written as y equal to something, so there's no manipulating we need to do. So what we can say, okay, we're going to use our second equation, and wherever we see a y, we're going to replace it with this equation. Right? So we're going to substitute our second equation into our first equation. Right? So we start off with our first equation. We have 1/2 x plus 2/3. Oh, there's the y. So we substitute in our second equation. So we have 1/4 x minus 5/3. And this equals the negative 1. Okay, just as before, our next step is to multiply through the brackets and collect our terms. So we have our 1/2 x here, and I need to multiply this 2/3 through the brackets. So 2/3 times 1/4 x becomes 2 over 12x. 2/3 times negative 5/3 becomes negative 10 over 9. And this equals negative 1. Okay? As the 2 over 12 can be simplified a bit further. Right? So it's usually easier if we work in lowest term. So the 2 over 12 can be rewritten as 1 over 6 because we can divide both numbers by 2. Okay, so now we need to collect our terms. We have an x here and an x there. Right? So the adding, so we need to add the terms together, but the numbers are fractions. So the rules for fractions, in order to add fractions together, you need to have a common denominator. We have 2 and a 6, so the common denominator would be a 6. So we need to multiply this by 3 and 3, right, to make a common denominator of 6. So 2 times 3 is a 6, and 3 times 1 is a 3. Right? So if we add these together, 3 plus 1 becomes 4 over 6x minus 10 over 9 is equal to negative 1. The 4 over 6 can be simplified. We can divide both numbers by 2. So we can get that down to 2/3. Okay. We move our number to the other side. So we have negative 10 over 9. To move it to the other side, we have to add 10 over 9. So it becomes 2/3 x is equal to negative 1 plus 10 over 9. Now once again, in order to have two numbers added together, their fraction, we need to have a common denominator. So we have 9 in the bottom here. So we need to multiply this by 9. So we end up with 2/3 x is equal to negative 9 over 9 plus 10 over 9. Now we can add these terms together. 2/3 x is equal to 1 over 9. Now we need to simply solve for x. We need to move the 2 and the 3 to the other side. All right, to get the 3 to the other side, we need to multiply by 3. So the 3 and the 3 cancel out. To move the 2 to the other side, we need to divide by 2. So the 2 and the 2 cancel out. So we end up with x is equal to 3 over 18, which is simplified to x is equal to 1 over 6. Now that we have an x value, we can find our y value by plugging into one of the equations. Right? So our equation for y was y is equal to 1/4 x minus 5/3. Now we can take our x value and substitute that into there. So we have y is equal to 1/4 times our x value, which was 1/6, minus 5 over 3. We clean this up. We end up being 1 over 24 minus 5/3. Okay. In order to subtract, we need to have a common denominator. So that would be 24. So we need to multiply this side by 8 to get the 24 here. So it equals 1 over 24. 5 times 8 is 40 over 24, which is equal to negative 39 over 24. You can divide both of these numbers by 3. So that ends up being negative 13 over 8. So that's the y value. So our solution would be x is equal to 1/6, and our y value is negative 13 over 8. Right? The steps are the same, but it's definitely a lot more difficult because we're working with fractions, so the arithmetic gets a bit harder to do. So pause the video, try the same thing for 2b here. So definitely not an easy question, right? And I'll walk you through this. So we have our equations 1 and 2. Our second equation is y is equal to an expression, so we can stick it straight into equation 1. By substituting it in, we get the first line here. We multiply the 4/5 through the brackets. We end up with this part here. Right? We clean up and we simplify the brackets here. Then we need to collect our like terms. But once again, they're fractions, so we need to have a common denominator. So the common denominator would be 10. Give them a common denominator, and we add the two numbers together, and we end up with 3 over 10. Plus 3 over 10 is equal to negative 2. We bring the 3 over 10 to the other side by subtracting it. Right? And we need to collect our terms together once again. So we need a common denominator, which would be 10. So we need to multiply the 2 by 10, so it becomes negative 20 over 10. So we have 3 over 10 is equal to 3 over 10x is equal to negative 23 over 10, and then we go to solve for x. Right? So we have our x is equal to negative 23 over 3. Then we take this x value and we plug it into our y equation. So where we see the x, we replace it with the negative 23 over 3. Then we simply multiply the numbers together and we collect our like terms, right? So we need a common denominator, so that in this case would be 24. And we have our two fractions, ends up being y is equal to negative 55 over 24. And your head might be a little spinning right now. Don't worry, there is another algebra method which I'm going to show you in the next lesson, which makes working with fractions a lot easier to do.